Greetings and salutations. Welcome to TryHackMe's Advent Cyber 2025. Today is day 14, and we're doing containers. DoorDasher's Demise. All right, so we'll open the tab here, scroll down, and as always, we will start our target machine, and we'll start the attack box. This could open up a new one. So we like to open up that in full screen. We're going to channel back to the previous tab, and we will minimize that. All right, let's continue with the story, shall we? All right, so the story is a bit longer, so let's dive in. It seemed as the sun rose this morning, it had already been decided that today would be another day of chaos in Wareville. At least that's the feeling all the folks at DoorDasher got. DoorDasher is Wareville's local food delivery site, a favorite of the workers in the best facility company, especially on long days when they get home from work and they just can't bring themselves to make dinner. I'm sure we've all been there. So one welfare resident was feeling particularly tired this morning and so decided to order breakfast, only to find King Melhair and his band of bunnies of battalion had seized control of yet another festival favorite. DoorDashers have been completely rebranded as Paparoo. All of the Ware's favorite dishes have been changed as well. Reports started flooding in that DoorDasher's call center, and not only from customers, but even the health safety food org was on the line too, utterly panicked. Apparently, multiple Wareville residents were choking on what turned out to be fragments of Santa's beard. Ware's authorities were left tangled in confusion today as Paparoo faced mounting backlash over reports of culinary impersonation. Customers across the region claim to have been served what appears to be authentic strands of Santa's beard in place of traditional noodles. A spokesperson for the Health and Safety Bureau confirmed that several dinners required gentle untangling, and one incident involved a customer achieving accidental facial hair synchronization. I mean, got spaghetti and Santa's beard mixing with his beard. I don't know. This is way out there, guys. All right, so next. Immediately, one of the security engineers managed to log on and make a script that would restore DoorDasher to its original state. But before he was able to run it, Sir Carabine caught wind of his attempt and locked him out of the system. All was lost until the SOC team realized they'll have access to the system via their monitoring pod, an uptime checker for the site. Your job as a SOC team member of DoorDasher, can you escape the container and escalate your privilege so you can finish what your team started. So we're going to be a red hat person, but be doing blue team activity. So we're using red hat skills to ultimately do a blue team skill. All right, so learning objectives. Learn how the container and Docker work, including images, layers, and the containers engine. Explore Docker, runtime, concepts, sockets, daemon APIs, and common containers. Escape/privilege escalation vectors. Apply these skills to investigate image, layers, escape a container, escalate privilege, and restore the DoorDasher service. Also, do not order Santa's beard pasta. So, as I always forget, we need to click this check button down here. Okay. So what do we got up here? You should be given access to Bomber-Tastic's user, which we will, which we can use to provide commands in the VM. And note that you will have the attack machine and the other machine, the target machine right here. So we have access to both. So if you look here, we can go back and forth between the two. It takes a moment for it to swap, but if you click over here, it will change to the attack box. See? Yeah, pretty cool. And I know we're going to need Firefox in a moment, so I'm just going to click that to get it loaded. All right, so we're going to the next section. Okay, so with containers, an explanation of them and how they work and how they don't work and how they're similar or different. This is a fairly big subject before we even get to the challenge. I'm going to try to summarize a bit, but I do recommend you read this fully if you don't have any idea what a Docker is or a container. So containers were something that was created to make life easier and also help segregate, segment different things from each other. And these things would be applications. So you may have a developer go, oh, that works fine on my system. I don't understand why it's not working on yours. Well, you may have different dependencies and libraries and all this stuff that has to be set up. But what if we could take all those little pieces and fragments and package them all together into a container, and then you could spin that up somewhere else. So someone could run the exact same thing that you created with all the dependencies intact here, here, here. So that's where containers come into play. And Docker is a type of container like Kubernetes is. All right, so continue here. So we're going to learn about installation, troubleshooting, conflicts. I'm going to keep on going through here. So what you need to realize is isolation, and they're different than, say, a VM, because you have two pictures, like VMs over here and containers over here. So you have your infrastructure, like the hardware, then you have the hypervisor, and then you have your guest OS bottom, binaries and libraries, and then the actual application. And as you can see, segregated, and segregated, right? And we have three different ones: green, orange, red. And then over here with containers, we have the infrastructure, the operating system, but now we have another layer, which is known as the container engine. Then we have the green app, the orange app, and the red app, which, as you can see, we are now only segregating, separating, isolating the apps only, and it can just do that via the container engine on one OS, or an OS that's on a hypervisor. So it is much more segregated. So if one app gets compromised, it shouldn't affect the other apps, nor the underlying operating system, just this one here, in good theory, in good practice. However, they all do share one thing. The containers do share one thing. Containers share the OS kernel, isolating only apps and their dependencies. So let's keep that in mind. So we also understand that application at scale. Microservices are a switch in the style of application architecture, where before it was a lot more common to deploy apps in monolithic fashion, built as a single unit, a single core base, which usually as a single executable. More and more companies are choosing to break down their application into parts based on business functionality. This way, if a specific part of their application receives high traffic loads, they can scale that part without having to scale the entire application. This is where lightweight nature of containers come into play, making them incredibly easy to scale to meet increasing demands. That also probably means it can be elastic, which means when that demand is gone, they can probably shrink it if necessary. They become the go-to choice for this increasing popularity architecture. This is why, over the last 10 years, you've started to see this term more and more. So, you have noticed a layer labeled container engine in the diagram. A container engine is software that builds, runs, manages, contains by leveraging the host system's OS, kernel features like namespaces and C groups. One example of container engine is Docker, which we will examine in more detail. Docker is a popular container engine that uses Docker files. All right, you may want to remember what Docker files is. It's a sample text script defining app environment and dependencies to build packages and run applications consistently across different systems. Docker is the container engine of choice at DoorDasher, and so what we will be interacting with in this interactive lab. So I actually have the questions down here, and we'll see that. Let's take a look. So you have what exact command lists running Docker containers, we don't know. What is the file used to define the instructions for building Docker images? What's the file, or what's the flag? And a bonus one. So what site is running on port 5002? This could also happen to be the password of the deploy user. This code could also happen to be the password of the deploy user. We'll keep that in mind. We should definitely change that password. And then, all right, so let's come back over here. And this Docker file is simple textbook defining the environment and dependency and builds packages. So I bet you if we take Docker files, we come back to our question and pop this one in here. Okay, we still got one. That was a little early, I know, but I kind of skimmed through this. Also, I think, did we get the website that we need to go to here? No. Okay. We haven't got it yet. Just want to make sure it wasn't posted earlier. So let's keep on scrolling down. Oh yeah, we already discussed what that is, pretty much. So the next thing that we want to talk about is escape, attack, and sockets. A container escape is a technique that enables code running inside a container to obtain writes or execute on the host kernel or other containers beyond its isolated environment, escaping. For example, creating a privileged container with access to the public internet from a test container with no internet access. Containers use server-side setup on the host. The CLI tool acts as the client, sending requests to the container daemon, which handles the actual container's management and execution. The runtime exposes an API server via Unix socket, runtime socket, to handle CLI and a daemon traffic. If an attacker can communicate with that socket from inside the container, they can exploit the runtime. This is how we would create the privileged container with internet access as mentioned in the previous example. We are now to the challenge. Perfect. So now it's time. Well, here is... Okay, so now it's time to start using the machine that we booted up in task 1. Let's check. So it wants us to run this Docker PS. And this will show us a services running on Docker. So we need to go back to the actual DoorDasher, the target machine. And once it loads up, we can paste in Docker PS. If it's not copied, we just type it in, right? Back. And we wait, and we wait. All right, and it's finally loaded. So it seems like, oh, there, it pasted twice. Ding, ding, ding. All right, so let's go. So as we can see, we have 1, 2, 3, 4. Got this uptime checker, the Dasher app, the Wareville times, and deployer. All right. And if you look on the backside here, you have like ports like 5003, 5001, and 5002. And you have like port 8080, 5002, local. Okay. So uptime checker is one that we know of. Dasher app is probably this 5001, 5002. Alright, so back here, what it wants us to do. It wants us to go to HTTP and the IP address in 5001. 5001 is the Dasher app. So let's go ahead and do that, and we will see what happens. So if you remember, we brought Firefox earlier. Welcome to Hopperoo. Wow. That part there is hard to read for me. Interesting. On my recording, it's not that hard to read, but this monitor I'm looking at, it's very hard to read. That's weird. Anyway, putting rid of that. As we can see, this site looks wrong. There's an egg. Just look at the Elf's Bane broth. Santa's beard pasta, authentic Italian with a festive twist. Oh my goodness. Anyway, this is disgusting. How can they have hair in their food? Top patron, outrage. Oh my goodness. Horrified customer. This is the worst one I've ever had. It's literally hair? Okay. So I'm betting we're going to go back to this one. So let's have this start loading as we go back here. And we're going to explore the uptime checker. So we're running the following command to access the uptime checker container. So we're typing docker, which means we're going to start with the docker, and we're going to do exec, which means we're going to run a docker command executable, which we're going to do -it, which means we're going to be pretty much entering the uptime checker, and we're going to be executing sh, which means bash. So we're going to be having an interactive bash. This is what this is going to do for us. Interactive bash on the uptime checker container. We typed it in, and there's just doing my just for the fun of, oh, we're root, cool. If we type post name, so we're not who we once were. Because we were previously, we were Miss Bombertastic, or yeah, Mr. Bombtastic. We aren't that anymore. After logging in, we want to check what sockets we have available to. We're going to do ls, which is list, then -la, which shows long form, plus all hidden ones at the var file run docker.socket. Alright, so if we can see this, then this is a chance for to break out our isolation, keeping the VM in. Look, we can see it. And let's see. I wonder what happens if we try to run docker commands. Or it's right here. The Docker documentation mentions that by default, there's a setting called Enhanced Container Isolation, which blocks containers from mounting the Docker socket to prevent malicious access to the Docker engine. In some cases, like when running test containers, they need Docker socket access. Docker provides a means to access containers via API directly. Let's see if we can. And we have that output. I wonder what happened if we would try to run Docker commands inside the Docker. By running Docker PS again, we can confirm that we can perform Docker commands interactive in the API. So we type, not there, not there either, Docker PS. We can run Docker commands with inside this Docker. And I just realized you guys may not be able to see something because my camera's in the way. Boop, we're up there for now. But yeah, this is kind of what we saw earlier. We were in the same command previously, just so you know. But I just realized, what is the exact command that lists Docker containers? We got it right here, Docker PS. It was accidentally clicked on that tab and ding. All right, so let's go back. We run that again. let's instead try to access deployer container, which is a privileged container, which probably means it's juicy, has juicy. So we want to do the Docker exe executable again with the interactive on the deployer container, and we're going to run a bash. All right, so we go on ahead and we paste that in here, Docker exe. We run it, and it looks as deployer. So we're going to type in who am I. We are now deployer, and just for giggles, what its host name is that big. Okay, cool. That string of text. Now that we're here, it wants us to run who am I, which we've done. We've made it. Oh, what's this? Check which user we are currently logged in as, explore the container, and find the flag. Once we made it, we have managed to make it to the container, where the script to restore the site is for its former version is. So we can find this container, we can store the version, save the day, run the recovery script in the root directory, and that will be what we'll do. We'll run as sudo, which means we'll run as super user. And the slash recovery means you do a slash, then the script, that's how you run scripts. And then we go back to the site to see what's happened. Okay, so let's go back here. While we're in here, let's just do ls. Do list ls-la. Yeah, nothing really in here. So we're gonna do cd, which means change directory, space .. which means you go back to the parent. And we're gonna do ls again. And look, we see a flag. So what do? We cat that baby. So cat flag.txt. And we do docker escape success. Doesn't that look nice? I'm gonna do Control-Shift-C, and then I'm gonna come over here to the questions. We paste that in there. Got another one. All right, let's actually finish what it wanted us to do though. It wanted us to do sudo /recovery. Okay, we can do that. So if you see, here is the recovery script. So we'll do sudo, and we'll do remember slash first, slash. Then recover, and you can push tab, it auto-completes it, which is so nice. And we'll click enter, and it's running some stuff. And if you look at the very bottom, look at this baby. The hackers have been defeated! You did it! Okay, so are we sure we really defeated them? Well, let's go back to our attack box here, and let's just refresh this. Hey, welcome to DoorDasher, Christmas delivery service. Look at this. Oh, these look much better. There's no reviews now, but hey, it's back to what it should be. I'm not sure what that is. Anyway, so with that running, you can see for yourself, refresh that, bam. Come back to our questionnaire. We only have one thing left. It's asking, what's this 5002, right? So how do we know what that is? We'll come back to our Docker part here, and we'll do that Docker PS. And if you look, there was this 02, which is the Whereville times. Okay. So going back to our Firefox, and we're going to change this 1 to a 2, and Whereville times. There's some words: health inspector, food, king malware, an assault, Italian cuisine. There's a word red and there's red. There's words in red. Actually, there's multiple here. Hopsec. Wait. Employee master 2025. What's the type? Because it was asking essentially a password. They want to do something simple as steganography. Would it? Deploy master? Surely it's just not hiding in plain sight, is it? Let's see. What was it? Deploy master 2025? Exclamation? Alright. We did it. We did it. And if you guys found that fun, you like the content, you can try Container Vulnerabilities Room there. And let's check that to finish this off. Congratulations. You did it. I'm proud of you. You're almost there, guys. This was day 14. Day 14. And you did it. Guess what? There's only 10 days left. Can't stop now. All right. Thank you so much for joining me. Hope you guys have a good rest of your weekend or day, whatever it may be, evening. Be safe, be secure. Please do good. Bye-bye.